All right, let's jump right in. We're talking about something pretty amazing today, how AI is becoming a super-powered assistant for doctors in one of the toughest fields imaginable, diagnosing brain tumors.
So, picture this. You're a doctor, a radiologist, and you've got this stack of MRI scans. We're talking hundreds of images for just one person. It's like you're searching for one tiny, crucial clue in this incredibly complex grayscale puzzle. And the stakes? Well, they couldn't be higher. So what if that doctor had a partner? Not another person, but an AI that's been trained to see things humans might miss. An AI that can scan that entire puzzle in seconds and say, hey, look right here. That's the whole idea. It's about giving our experts a superpower.
Okay, so let's get into the heart of the problem here. Why is this even necessary? It all comes down to what you could call a diagnostic dilemma. I mean, it's pretty simple, right? When you're talking about brain tumors, you are literally in a race against time. Every single second, every minute, it all matters. Getting that diagnosis right and getting it fast can change everything for a patient. The clock is just always ticking.
And doing this by hand? It's tough. First off, it takes a ton of time. And let's be real, even the best experts are human. They get tired, and one radiologist might interpret a shadow just a little differently than another. That's not a criticism, it's just reality. And that little bit of difference, that's exactly where a super consistent AI can be a total game changer.
So how did they build an AI to solve this? Well, they didn't just build one, they built a team. Think of it as an AI dream team, with two different specialists working together on the same case. Okay, so here's the team. You've got two detectives on the mission. First up is the where detective. This AI, a UNet model, is a master of geography. Its whole job is to find the exact location, size, and shape of the tumor. It literally draws a perfect outline right around it, creating this thing called a digital mask. Then, once the where detective is done, the what detective steps in. This is a CNN model, and it's the expert profiler. It looks at what the first AI found and says, okay, I know what this is. It identifies the specific type of tumor we're dealing with.
So you're probably wondering, how on earth do you teach an AI to see a tumor? Well, you send it to school, a really intense medical school, but for computers.
And what was the curriculum? Get this. For each of its jobs, finding the spot and identifying it, the AI was trained on 4,500 different MRI scans. That is a huge amount of data. It's like it studied a medical library the size of a small town.
And it wasn't just about quantity, right? The quality and variety were key. They made sure the AI saw a good mix of everything: glioma, meningioma, pituitary tumors, and, just as important, a whole bunch of scans with no tumor at all. Why? Because you need the AI to be just as good at saying everything's clear as it is at finding a problem. It prevents the system from getting, well, paranoid and seeing things that aren't there.
So here's the how. For the where detective, the UNet, the trainers basically gave it thousands of scans with the answer key. They showed it images where human experts had already traced the tumor's edge perfectly. The AI's job was to learn to copy that, pixel by perfect pixel. For the what detective, the CNN, it was like a giant flashcard session. This is a glioma. See the pattern? This is a meningioma. See how the texture is different? Over and over until it could tell them apart on its own.
Okay, so training is over, the AI has graduated. Now for the big question. Did it actually work? It's test time. Let's see the results.
First up, our where detective. The metric here is called a dice coefficient, which is a fancy way of asking how well did the AI's drawing match the expert's drawing. The answer? 90%. That means the AI's outline of the tumor was 90% identical to the one drawn by a human specialist. That is an incredible level of precision.
And what detective, the one that identifies the tumor type, it scored a mind-blowing 95.4% accuracy. Let that sink in. On images it had never seen before, it got the diagnosis right more than 95 times out of 100. That's a level of confidence that is just wow.
So, those numbers are amazing. But amazing numbers in a research paper don't help patients, right? The real magic is taking all that complex code and turning it into something a doctor can actually click on and use in a clinic.
And they made it ridiculously simple. Step 1, a doctor uploads an MRI scan. Step 2, the AI system does its thing, running both detective models at once. And step 3, a full, detailed report pops out. We're talking about a process that could take hours being crunched down into just a few seconds. And the interface is super intuitive. It's not a bunch of code. You see the original MRI right next to the one where the AI has highlighted the tumor, and then boom, right there is the diagnosis. It's all laid out, side by side, so the doctor can see everything at a single glance.
And the final piece of the puzzle? The system bundles everything up into a professional, downloadable PDF report. You get the images, the AI's conclusion, and, this is really cool, a confidence score. So the AI tells you not just what it thinks, but how sure it is. It's a complete package ready to go right into the patient's file.
So it really makes you wonder, right? Is this the future of diagnosis? It's not about taking the human out of the equation. It's about taking human expertise and amplifying it with AI, giving our best doctors a tool that makes them even better, leading to faster, more accurate answers for everyone.